Hi guys, we're here again. Today, I'm gonna try to speculate GPT-4's model, data, and cost to train. And this is our speech and NLP paper reading channel. And also, here are the barcodes for you to scan. And this is the QR code for our weekly or bi-weekly meetup. It's called Bay Area Speech and NLP. Please join our meetup group if you feel interested. And don't forget to subscribe to our channel if you want to get the latest speech and NLP archive work, and we're going to be reading these latest works. So I think all of you have been fascinated by the powerfulness of the GPT-3, especially their web portal, ChatGPT. And I think just a few days ago, OpenAI claimed that they have the latest GPT-4 work. But unfortunately, when I want to read the paper to you guys, I read their GPT-4 technical report. I do have it in my channel. You can watch it. But I found it does not mention anything about the model, the data they use to train their model, and also how much does it cost to train, aka the number of GPUs. So here comes the question: why do I want to make this video? Why can't you just be like other paper readers YouTube channel, just to stick to the paper's content? I do have remember that there are many commenters in my channel. They're saying that way you should stick to the content of the paper. I told them I want to give them my thoughts on the paper, but not all of them are interested. But today, I think the issue is OpenAI wasn't as open as it is before the pandemic. I think you guys may have seen the GPT-1 paper back in 2018, and also GPT-2 and 3 paper in 19 and 20th. They all talk about the model data, the amount of. They didn't talk about the amount of GPU they use to train the model, but there are lots of details. So anyone who does not have time to read the paper, you can definitely go to some paper readers channel and just grab the main thing about it. But the thing is, since GPT-4, OpenAI stopped to share their model details with the readers. So suppose you still call yourself a NLP researcher, or you suppose you are an engineer who wants to go beyond OpenAI's framework. Say you want to do something better than the GPT-4, or say you want to or develop your own GPT model. Then you cannot start from ground zero. So you have at least to know what GPT people have done in GPT-4. So let's start with model. So I have a paper reading on GPT-3. So I think I covered lots about how their model was designed in that paper. You can scan the QR code to get to the YouTube recording of my reading. And today I'm gonna briefly go over the GPT-123 model's architecture. Okay, this image. The loss or the objective should be shown in the equation 1. So given a history of word tokens, you want to maximize the probability of the next word's probability. How do you say that? So you want to maximize the word probability given the word history, okay? And then you want to maximize the overall, the sum the log probability. That makes sense, right? And then, so how do they achieve this goal? So first of all, they gather the context vector of tokens. They multiply that with the embedding matrix, token embedding matrix. And this is the position embedding matrix. If you got confused about the positional embedding matrix, let me tell you, it's important or essential, but it doesn't help you, or even if you do not understand the usage of WP, it's okay. All you have to know here is that the H0 vector comes from the input of the word history multiplied with a matrix, and the matrix it should be learnable. And then the H0 should be passed through a transformer block. Then you get the H1, right? Then you go with H1, you get H2. I think in transformer 3, they got 96 transformer blocks stacked on top of each other. So this is a very large model or very deep model. And then once you get the final layer H sub n, so you can see it multiply with the original token embedding matrix WE here, and then they come up with the probability of the next word. Okay, and that's the very vanilla. How do you say vanilla? I don't think it should be vanilla. It's very rudimentary to lots of people who are working on algorithm, because the algorithm is very vanilla. Even I think even the high school students or maybe sophomore student can understand the equation. Okay. Then, as we all know, in the GPT-4, the OpenAI people, they claim that they would release the model that allows people to not only input the text, but also input the image. Remember, I think in the last video I made, I showed you an example that they asked the student, they asked the GPT-4 a physical question, ask it to deduct the certain type of equations given the text. But besides the text, they also supplement the GPT-4 with a figure illustrating the physical condition, okay? And then I think that was also got input into the GPT-4, and GPT-4 was capable of taking both the text and image and generate the next word token, aka the answer to the question. I do have thought about this, what type of model they could be using during the past few days. Based on my knowings about the OpenAI people, for example, the first author of the GPT-1 and 2 paper, I think is Alec Radford, and also he's also the guy who is the first author of the paper clip, right? It's about how to train a pre-trained model for image. But I can see that his style, or the OpenAI people's style, is that they do not try to introduce sophisticated loss function. They tend to just use vanilla loss for example. This loss, it's vanilla loss, right? It's just a probability, very simplistic, very simple probabilistic loss. And also they like to stick with the transformer. I understand this because transformer is very fast during training. If you do not understand this, you can search the transformer in my channel. I have a paper reading of Attention is All You Need. It compares the transformers training complexity with the CNN, RNN, and what else? DN probably. I don't think it has DN. Just compare with RN and the CNN, I think. Transformer is fairly fast. And I believe that they might have done something to the transformer because there are lots of people who have been trying to accelerate the speed of transformer, even though transformer is very fast. Okay. So why transformer is very fast? Pause the video for 10 seconds and answer the question yourself. Yes, it's because of the self-attention. So this is my speculation of what is being done in the text plus vision GPT-4 model. I have to say that GPT-4 people does not say the model is like this. This is only my speculation, okay? And then you can see the equation here. In the past, it's U times WE plus WP, right? But in this one, I think they would have an extra term, which is V multiplied with another matrix. And then what does the V stand for? V is the image encoder's output. So you got send the image through a encoder. The encoder is also indeed transformer, probably. I think I have read the paper clip. You can search the clip in my channel. They have demonstrated that even the Alex Radford demonstrated that vision, I think it's vision transformer works better than ResNet encoder. So I think they would stick to the vision VIL transformer, something like this, or vision transformer. Sorry, I'm not a computer vision people. I may have said some terminology less accurate, but the concept is that I think they would still use transformer encoder for image and get the embedding for image, aka V, and then as long as you have the V multiply a matrix, then you can make the dimension of the U times WE and the V times WE astrophy to be equivalent, right? Then they can be multiplied together. And the WP is trivial. It's related to the text. I don't think it has anything to do with the image. And then the rest, the second equation is the same, although the H0 has been changed. Then you can see everything transformer afterward is the same. And how about the getting the probability part? I think in this part, it has nothing to do with the image right now. Why? Because I think according to the case study shown in the GPT-4 Tech Report, it does not try to generate another image. So it's all about predicting the next word or text generation. So they all only have to predict this P of U, the probability of next word. Okay, this is the same. Talking about updating the parameters, I would say there can be two choices, and you can see that if you look at the back propagation, once you have the error propagated from the P of U, it can update the WE for sure, right? And the transformer blocks can also be updated as the GPT-3. But up to here, it's a choice that OpenAI people can update their image encoder or not. You see what I'm saying? And I think it's very likely for them to update the image encoder because U or V are definitely correlated. They should be updated. This is what I'm thinking. I think some of you guys may have thought that, okay, wait, how about they apply some? Can they have like a 2-tower structure? So I think what you guys mean is instead of having this combine the vision part together with the text part, they can keep the text part and the vision part separately, right? They can choose not to touch the text-based transformer, and they can have on the next to it, they can have a separated text transformer, and then they can have some type of cross attention from vision to text and text to vision. This is possible. I didn't say it's not possible, but I think the problem is that anything you have the cross attention, I think it will slow down the training a lot. Because cross attention, in my opinion, or in my understanding, is not self attention. Self attention is very fast. Cross attention is not. For them, they want to train the super large model in an acceptable time. And although they may agree with you that the cross attention may give them better model performance, but if they can train their model with more data, with a simpler model architecture, that means they can still get better model performance, right? You get what I'm saying, right? So, okay. But this is only speculation, okay? If you do not agree with me, comment on the comment section. If you want to have some comments or suggestions, also comment in the comment section. This is all about discussion. And I didn't say that I'm superior than certain type of people or I'm more smart than some other people. I just want to say that because as a researcher, it is sad to see that OpenAI stopped being open about their model. I think as a researcher in the domain who has benefited from the community, I want to do something to return back to the community. Just give one input to the community and try to make the large language model research to be as open as possible. That's my personal goal. All right. What's next? Data. Data-wise, I think it's also very hard to speculate. Why do I say this? The reason was because even in the GPT-3, they didn't say very much about their data. Only they're saying that they're using 300 billion tokens. But I do not think they have said anything in the instruction GPT, which was something like a pre-GPT version of their final ChatGPT. So definitely you can see that GPT-3 paper was published in 2020 or 2021, 2020, I think. So it's 3 years or 2.5 years from now. And the GPT-3 or ChatGPT might have way more data than GPT-3. And after they launched the ChatGPT, they got lots of data, especially data with human feedbacks. Remember when you play with the ChatGPT, they have the thumb up or thumb down? Lots of people click that. Give them the reason why they do not like it. There are lots of people that are trying to help OpenAI to improve their model by providing their feedbacks. This is called human feedbacks. Human feedbacks is very important in training their model, as stated by their instruction GPT paper. I also have a paper reading of instruction GPT in my channel. So how many tokens they have. I would rather not say because it's really hard to estimate. But my guess is that in GPT-3, they have 300 billion tokens. I think right now they shouldn't have one magnitude more than what they had 2.5 years ago. Let's say it's less than 3 trillion tokens. So image data, there's no clue. Only clue I think I can look into should be OpenAI's clip. So as you know, the first author of the clip is also the first author of the GPT-1 and 2. I think they have lots of data, image data in the clip, something like 400 million images. And also remember in the clip data training, they have the text with image, but it's very questionable to me that they should have some more data. Not the data they use in the clip, because remember in the data they use in the clip, they only have the image and the text description associated with the text, the image. What they actually need is something like this. The prompt has text and image, or how to say that? Sorry, let me start from the beginning. What the training data they should have in the GPT-4 should be something like this. It has text and also image. And the image does not necessarily have to be aligned with the text. Think about the news article. They have something in the beginning about summary of the article, and they have a image talking about the news, showing something about the news, and there's finally some conclusions. It's related, but they may not be perfectly aligned like the data that people use in the clip data. Clip data is more like a text is used to describe the text. But does that mean they shouldn't use the clip data? The data they use in clip training? I mean, it's everything is unsupervised training. Okay, I think they can still use the clip data to train their model. But I don't think that's a good data to train their model on, because eventually they're going to be facing some, for example, exam cases. For example, you show the students a paragraph of text question and also a picture describing the scenario. This data, I don't think it has shown in the clip, because clip is paired data. So model parameters, I think it's also, model parameters is closely associated with the data, okay, and the model architecture. So I think last week, a few weeks ago, or 1 month ago, there was rumor saying that the GPT-4 model should be 1,000 trillion parameters. No way, definitely no way. Even it won't be larger than 10 trillion parameters, I think, because the GPT-3 model is only, or instruction GPT model is only having a size of 0.175 trillion parameters. It's very unlikely for the GPT model to go 2 magnitude larger than its predecessor. So to me, it's very likely to be less than 1 trillion parameters, or around, or on the magnitude of 1 trillion parameters, like less than 3, I think, less than 3 trillion parameters. But it could also be less than 1 trillion parameters. This is my guess. And the reason why, because if you watch the last weekly review I made, I mentioned that in the DeepMind research, when they talk about their model, Chichala, right here. Chinchilla. They have a graph comparing the training cost versus the model size. It turns out to me that if you have a model that's too large, you probably do not have the enough amount of training resources. What do I mean? What do I mean by training resources? It including two things. First is the number of GPUs or the training clusters. The second is the data. I think it's very unlikely for the data to explode magnitude higher than 3 years ago. So I think it's only at least at most increase of 1 magnitude. That's very a lot. So let's take a quick look at the table I compiled for you guys. I read the original GPT-3 paper, and this is NVIDIA's Megatron tooling NLG, and this is a DeepMind Chinchilla, and this is Google's multimodal large language model, and this is by Chinese researchers, GLM, and this is by European researchers, Bloom, and this is by Meta AI, Llama, and this is nothing you know about GPT-4. I think the most interesting thing you can see here is that most of them does not have training tokens greater than 1.5 trillion tokens. Even the latest Facebook or Meta model was trained last month. They only have 1.4 trillion tokens. And the amount of GPUs. As we know that Meta invests a lot in, and also Google invests a lot in training this super large model, and you can see that they only have thousands of A100 or A100 like GPUs, and for now, it's very unlikely for them to have 1 magnitude more GPUs. Look at OpenAI, okay? I know OpenAI has a lot of money, but it's very unlikely for them to have cost to train. Very unlikely for them to have more than 10,800 GPUs, because the thing is, they do not have enough amount of data to train their model. That's the issue. I do not worry too much about they are dedicated to train a larger language model. But the thing is, due to the lack of available training data they can get. But you would say, okay, wait, they get lots of data from the daily users' activity. They collect data from user. But the thing is, those data, they have a lots of repeated text compared to what they have been collected, right? And most of them, they only get questions. They don't get answers, okay? So, but for the original or the past training data they have the questions and answers, right? They have the whole text. But I think definitely they would have more than 2,800 GPUs. But that's not something that everybody can afford. Okay, I'm gonna stop here. So how do you like my comments or speculation? If you enjoyed watching this, please subscribe our channel by scanning the QR code of the OLAWay YouTube channel. And if you want to attend our live session and join our discussion, you can subscribe the QR code on the right. It's a Bay Area Speech and NLP Meetup. So we read the latest speech and NLP archived works. And thank you for watching. And feel free to comment. Bye.